So let's look at yet another example. Okay. Suppose blood pressure for a sample of 3,534 people has a mean of I'm going to avoid there, has a mean of 127.3 and a sample standard deviation of 19. Okay, we want to find the 95% confidence interval. All right. Again, let's start by specifying what we already know, right? So let X be blood pressure. Okay, so we have a sample of 34. So N is 3,534. X bar is going to be 127.3. The sample standard deviation is 19. Right. We're interested in the 95% confidence interval, and so the confidence level is 95. Right. The confidence coefficient, 95%. The confidence coefficient is 0.95. So alpha is 1 minus 0.95, which is 0.05. Okay, so that gives us alpha over 2 of 0.05 divided by 2, which is 0.025. Okay, and then here we have a sample size of 3,334. So our degrees of freedom is n minus 1, which is 3,533. Okay, so now let's apply our formula. We have the 95% confidence interval, which is equal to X bar plus minus T sub alpha over 2 with n minus 1 degrees of freedom times Sx, right, the sample standard deviation divided by the square root of the sample size. Okay, so X bar here is 127.3 plus minus T of 0.025 with 3,533 degrees of freedom times 19 divided by the square root of 3,534. Okay, so the only thing we need to know in order to do the calculation is a t value, right? So let's go to the t table. Here I have a portion of your t table, right? If you remember, in the previous video I mentioned that the t distribution approaches the standard normal as the degrees of freedom gets large. Okay, so if you look in the table, the degrees of freedom goes up until 95, 96, 97, up until 100, right? then it jumps to 120, 140, and so on and so forth until 200. And then the next row is infinity. Okay, so whenever the degrees of freedom gets above 200, you use this last row, this infinity row. Okay, so here we're interested in t sub 0.025 with infinity degrees of freedom. Right, so you would look at this last row, look under column 0.025, and that gives you a t value of 1.96. Okay, so with that t value, you plug it into the formula. So this is going to be equal to 127.3, right, plus minus 1.96 times 19 divided by the square root of 3,534. Okay, and I'm gonna skip the math, but if you work out the math, this is the interval from 126.7 to 127.9. Okay, again, in order to use this formula, we need to know that x bar is normally distributed, right? So for formula to work, the sample means must be normal. Okay, and in this case, x bar is normal because even though we don't know the distribution of x, we have a sample size which is 3,534, which is greater than 30, right? And so that means that the central limit theorem applies. Okay.